All right, so we're splitting 6/6 into 2 days. So we're going to spend a little bit more time on each problem than we normally would in a regular lesson. So we're going to solve logarithms with equations. All right. So we've done a little bit of this already, so this one should look somewhat familiar. So the base to the opposite side equals what we're taking the log of. So 4 squared is 16 equals x. Pretty easy. You could double check that by doing the change of base rule. So log of 16 over log of 4 should equal 2. Okay. Log 4 x plus 2 equals log 4 of 8. So we're going to use all of those rules that we've already used. So the logs are on both sides. There's no plus minuses floating around. So we get to drop the logarithms. We get x plus 2 equals 8. X equals 6. Everything looks good. All right, I might need extra room, so I'm going to go to a new whiteboard. All right, 3 log base 2 of x equals negative log base 2 of 27. Okay, so you can't do anything with logarithms as long as you have multiples in the front. So we need to move them both up as exponents. So we get log base 2 of x cubed equals log base 2, 27 to the negative 1. Again, we get to cancel out the log base 2's. We get x cubed equals 27 to the negative 1. Before we're going to do anything, we need to get rid of that negative 1 exponent, 1 over 27. And to solve this, we're going to not take the cube root. That's not what it asks us to do, but I guess that would work as well. We're going to solve it the way the book does it, which is subtract 1 over 27. Okay, and then we're going to do the cubic trinomial, not the cubic trinomial, the difference of cubes is what I wanted. Okay, so we get the cube root of x cubed is x. The cube root of 1 over 27 is 1/3. We square the front term. We multiply the two terms together with a plus. And we square the back term, 1/9. Okay, this back trinomial is not going to give us a factor at all. So we're only going to set the front one equal to 0. So x equals 1/3. All right. Take another step up. Okay, so all of those we drop the log except for the very first one. This next one we can't do that. Log of x plus 15 equals 2. And so this one we're going to use the other rule where we multiply them together if it's a plus. So log x plus 15 equals 2. So there's an understood 10 there, so we're going to rewrite in exponential form. The base to the opposite side equals what we're taking the log of. Okay. Then we're going to subtract to make it a trinomial. 0 equals x squared plus 15x minus 100. Then we're going to factor. We get x minus or plus 20, x minus 5. So x equals negative 20 or a positive 5. So before we decide what works and doesn't work, we need to go back and check what we're taking the log of. If we plug negative 20 in, we get the log of a negative number, so it crosses off. Then when we check 5 works. We get log of 5, we get log of 20. Those both work, so the answer is 5. So again, along those lines, this is similar, just a half step harder. So x plus 7 plus log 2x plus 8 equals 1. So we're going to multiply them together again. X plus 7, x plus 8. The log to the base to the opposite side equals what you're taking the log of. So when I FOIL it out, I get x squared plus 15x plus 56. I'm going to subtract 2. And I get 54. And I FOIL and I get x plus, or sorry, I factored out x plus 9, x plus 6. And I get 2 negative numbers. So don't automatically assume the negative numbers are going to not work out. So again, I'm going to go back and look, what am I taking the log of? When I plug negative 9 in, I'm going to get a negative 2 in the front one, so that doesn't work. When I plug negative 6 in, I get positive 1 and I get positive 2. So negative 6 does work. So negative 6 is the answer. All right, log 3 x plus 1 plus log 3 x plus 4 equals 2. This one is one step harder, even though it looks just like the last one. So again, we're going to multiply them. So the base to the opposite side equals what we're taking the log of. It simplifies to x squared plus 5x plus 4. We're going to subtract 9. And it's not going to factor. So there'll be one problem probably where it doesn't factor. And because of this odd number in the middle, I don't really like completing the square. That's totally up to you. But I'm going to do the quadratic formula. So x equals a negative b plus minus square root b squared minus 4 times a times c all over 2a. So negative 5 plus minus 25 plus 20 over 2, negative 5 plus minus 45 over 2. That has a perfect square. And negative 5 minus, it's 9 times 5, so I get 3 root 5 over 2. And the negative version is not going to work because I have a plus 1, so anything would have to be smaller than 1. And it's definitely not, or it would have to be, sorry, bigger than 1. Well, this negative piece is definitely going to be less than, and you could check. So the only one that works here is negative 5 plus 3 root 5 over 2. So the negative version does not work. Okay, one last problem. So we had it where we canceled them on both sides. We had it where we multiplied. Well, we need to deal with the fact that it does happen when we divide. So here's the one where we're going to divide. And I think I'm going to run out of room. So we'll write it as 2 separate lines. So log a x minus 1 minus log a x plus 6 equals log a x minus 2 minus log a x plus 3. Okay, so minuses mean division. So log a x minus 1 over x plus 6 equals log a x minus 2 over x plus 3. Now we get to cancel the logs. And in order to solve this, we're going to multiply by the common denominator, or you can cross multiply. So here's my cross multiplication. So I get x minus 1 times x plus 3 equals x minus 2, x plus 6. So on the left side, when I simplify, I get x squared plus 2x minus 3. On the right, I get x squared plus 4x minus 12. And then I'm going to move everything back and forth, but notice that I have x squareds on each side. So if I subtract one, they're going to go away. Okay, so I'm going to subtract 2x. I'm going to add 12 and divide by 2. And 9/2 works perfectly. Again, go back and double check at the very top. Those work just fine. So those are all the first set of problems. The other set of problems are going to be an entirely different set, and they're going to be set up differently with equal marks. So that's why I split them into 2 sets.